Hello, and welcome to a video on calculating limiting reactant. Alright, in this video we start out with moles and we need to find moles. But we're given moles of multiple reactants, so it is a limiting reactant problem. We have to first find out what the limiting reactant is, and then use that to find the amount of product. Alright, and this video covers one of several methods of doing this kind of problem, and we'll just arbitrarily call this method A. Okay, so we have a reaction occurring here, a combustion between propane and oxygen to make carbon dioxide. So we have our fuel plus oxygen gives CO2 and H2O. When we balance this equation, that's what we get. Great. Now we can look at what we're given. We're given 3 moles of the propane and 10 moles of the oxygen. So we're given amounts of 2 different substances on the reactant side of the equation. That lets us know, ding ding, this is limiting reactant problem. All right. Now we have to decide what is the limiting reactant. Method A covers one way of doing that. First off, we'll use that first amount of reactant that we're given, and we'll calculate how many moles of product, the amount of product that's formed from it. Then we do it again for the next reactant. For step 3, we compare the answers from steps 1 and 2. The smaller amount of those 2 is the correct response. And then you just check to make sure it's in the units that you need to solve the problem. All right, let's go through this. I'm going to calculate how many moles of CO2 can I get from the available C3H8 propane. And I will end up comparing it against the moles of CO2 that I can get from the available O2. All right, so let's calculate this. From the available C3H8, the available amount is 3.0 moles of the propane. Now I need to convert it from the moles of propane to moles of CO2. I do that by the mol-mol ratio. Put the moles of C3H8 on the bottom so it divides out, and the moles of what I want on the top. The numbers still need to go in there. Let's see. I get those numbers from the balanced chemical equation. So this 3 came from the balanced chemical equation right there. 3 times 3 divided by 1. Oh, I'm so glad I chose nice, easy numbers for myself. 9 moles of CO2 from the available C3H8 propane. Now let's calculate what we get from the O2 that's available. That's 10.0 moles of O2. I'll do a mol-to-mol ratio with moles of O2 on the bottom and moles of the product that the question asks about at the top. Moles of O2, let's see, there's a 5 out in front in the balanced chemical equation for O2 and a 3 out in front for CO2. Doing this without a calculator, I see that 2 times 3 is 6. So I can get 6 moles from the available oxygen. Now I compare those 2 numbers. Again, I'm comparing those 2 moles amounts. 9 moles of CO2 from the available propane and 6 moles of CO2 formed from the available O2. The 6 is the smaller number, and so I can see that 6 moles of O2 are actually formed, and that O2 is a limiting reactant. And that is how to do the limiting reactant problem, given moles, solve for moles, using method A. We have other videos with other methods, and I hope you'll check them out and discover which one works best for you. See you in the next video.